All right, this should work. I pushed the enable auto start button on this YouTube live, so I shouldn't have to say go live. This just happened. Magical. All right, it's going. All right, so today I want to take a look at GeometryEngine, right? GeometryEngine is ridiculously powerful in the JavaScript API. It's always been in the API. It was in the 3x version of the API. That's in the 4x version. The API is the same between 3x and 4x. So if you're a pro at 3x GeometryEngine, you can jump right into 4x and move right ahead, right? There's a GeometryEngine async as well that will run in a worker thread. So this is asynchronous. It's promise based, so you can do a wait on all of these methods and everything. That's pretty much the only difference that you would need to do is using async and wait there. So let's take a look at some stuff here. Now I'm going to cover, I think I'm going to cover most of the methods on here except some of the more obvious ones, things like buffer and stuff. I'm not going to bother covering because I think people will know what a buffer is, right? I've seen a couple questions pop up every now and then about some of the methods, kind of like what they mean, what they do, what do they really do, kind of a thing. Some of them I won't really be able to do correctly because I have to build a full app to kind of demonstrate how some of the stuff works, but it's okay. Don't worry about it. Okay, let's go ahead and try some of this out. So like I said, I won't cover buffer, but I'll cover clip. And I'm going to take advantage. I have a code pen here that I'm going to use for some stuff, but I'm also going to abuse the sandbox that we've got here that does sketch widget stuff already, right? And I've got a little button here, test, and I'm just going to run some methods on test. So what does clip do? So if I look at the doc for clip here, calculates the clip geometry from a target geometry by an envelope. Now when you say envelope, I'm assuming it just means extent, right? So that could be an envelope, that could be the extent of a map view, or it could be like the extent of some lines, multi-points, or a random polygon, right? All of those have an extent of some sort that they take up. I know it's just the four corners. So let me do it this way here. So on my button click here, where is that? Oh, here. Okay. So let's ignore this thing here. So we're going to do a clip. Now we're going to clip this boundary polygon. The boundary polygon is this white line right here. And we're going to clip that based on, let's just do the view extent, all right? And I'm going to go ahead and add that to the map. And it's just going to be like a black box. So let's refresh this. Let me zoom in, like say right here somewhere, right? Okay. I click test, and bam. There's the clipped geometry. Pretty straightforward. Okay, I don't think that's a lot of magic to that. And of course it's fast. It's a pretty simple operation to clip a geometry. Now what if I do it based on the buffers? Right, so let's do the, well, I don't think that's not going to work. I need to create an extent for it to work. So just stick with the view. Okay, now this could be pretty useful if you're zoom your map into a location and maybe you just want to clip out all of these geometries that are within the view extent and then do something with them later. This is the kind of thing you can do. You clip out the geometries, whether it's like a road network, some polygons, whatever it might be, and save them somewhere, and you could do something with them later on, right? I mean, it's cool stuff. All right, so that's clip. Contains, I think contains is pretty straightforward. This sample actually does a pretty good job of showing how contains works, right? So it's going to check two things. The sample is going to check whether or not these buffers here, these I guess they'd be like a light brown, tan colored buffers, intersect with this blue box. If they intersect the blue box, you get this thing here. Oh, I know, I think I jacked this one. Okay, contains, I need to change this contains here. Let's do that. I was messing with this code, you can tell. All right, so if this blue box intersects this buffered area, it's going to highlight it this red hatch saying that's not allowed, right? It's kind of what that means. It's not, you're not allowed to put it there. And you can do this in editing, so you can prevent edits happening in a certain way that maybe you don't want to allow edits to happen when they overlap features or intersect other features. So it does need to be contained inside this boundary box though. So if I go outside, I'm not allowed. Inside allowed, outside not allowed, right? That's how contains and intersects kind of works. Okay, I think these two are pretty self-explanatory GeometryEngine methods you can use. All right, so let's check out some other stuff in here. So this contains convex hole. Convex hole is kind of cool. Convex hole, you either give it a single geometry or a bag of geometries, and it's just going to go ahead and create a convex hole for them. I'll do it with the line. I've done this kind of stuff before where, let's do this. Let me copy some code over here. Where am I at? I'm all over the place, people. Okay, let's copy this. Put it over here. So I've actually used convex hole before for things like clusters. So you find all the points that are inside of a cluster, and then you create a convex hole of those clustered points to just kind of highlight the area on the map, and maybe don't show the points, you only show the convex hole. Especially if there's like, you know, a cluster is made up of like 10,000 of them. I mean, you have a cluster point showing where they are, but maybe you want to show the area that they're in, right? That's kind of where this would be useful for. So we're going to go ahead and create a convex hole for the line. Convex hole. I think it takes a single geometry. All right, so okay, so let's do this. Save that. So if I start drawing, all right, so there's my convex hole for that line. All right, you can see that the convex hole doesn't clip out this area, right? Because technically the convex hole is all this too. So if I drew a line that had some holes in it, like so, funky, right? That's what you get for a convex hole. That's the area that it takes up on the screen. Okay, so that's pretty useful. That's a nice one. Crosses. Indicates that one geometry crosses another, right? So this is really more for like if you're dealing with you want to do some lines, right? So let's do something like, I'm not going to add anything right now. This is just a Boolean result, right? So I'm going to say crosses. Does the line cross the polygon? Yeah, that's right. Does my line cross polygon? So let's draw a polygon. And I'm going to draw a line. False. That line does not cross the polygon. But if I do another one, true. That line does cross the polygon. Right. So again, you would use that in like an editing type situation where you don't want to allow lines to be drawn over. You know, if you're adding utility lines to something and you don't want them to be added over residential property, then you could have that rule in there, and you have your little editing setup going. Cut. Okay, split the input polyline or polygon where it crosses a cutting polyline, right? So this is if you want to split a line or polygon in half, kind of a situation. So let's try that. So I want to do a cut. Let's try this. I don't know if this is going to do what I want it to do. You won't be able to tell. I'll show you right now what I mean. So if I draw this here, I probably should fix my stuff. So I do that. All right, it's invalid property needs to be one of geometry extent or multi-point. What am I doing? So wait, cut. What's the first argument for cut? So it takes the geometry and the cutter, right? And returns two things. This worked from yesterday. What did I do wrong? So it takes my polygon, and it takes my line. It should cut them, I think. So what's it telling me here? Value needs to be one of every extent. Geometry. Ooh, that might be a good one. The extent might be interesting. That would stand out a bit more, right? So I wonder why that didn't work. Okay, let's see here. I'm setting. Yeah, so I'm cloning that. Let me do that. I don't think I need to do the clones on here, but I'll do them anyway. Yeah, I don't think that's necessary anymore today. But okay, so there's my result. Oh, because it returns two geometries. My bad. It returns two of them. That's where the error is coming from. To add that graphic. You'll see what I mean right now. There's my polygon. My line, and I cut. So I have two. That result isn't a single geometry. It's two geometries. It's going to be this polygon here and this polygon here. And you can tell that if I just go here and we click on type. Type is polygon, right? So yeah, That's how that works. I would show it, but then there'd just be two black squares in there. You wouldn't really be able to tell much of a difference. Okay, so now let's go ahead and check out the next one. All right. Densify. Okay, this one could be interesting. This one could be kind of fun. So densify geometries by plotting points between existing vertices. Basically, you want to add data to your geometry, right? Why would you want to do something like that? Well, if you set this up correctly with the right max segment length and the right units, then you could go ahead and like smooth out a line. You want to densify it a bit more. So let me see if I can accomplish that. I'm not making any promises here. So let's densify. And we're going to densify a line. We're going to add that line here. And let's go ahead and densify it by... I don't know what my map scale is. I'm horrible at units on the map. Let's say 5 meters. That might be too much. Too little. Who knows, right? It's all magic. Okay, so let's go ahead and try to draw what might be considered a rough circle. And there is my densified geometry. Didn't really do what I wanted to do. This one's a densified geometry here. Yeah, but it's adding points to my geometry. All right, so that's what I was trying to do. So I think if I click this, no, I don't think that, because it's not the same graphics layer that is being used by Sketch Widget, right? Yeah, it's got its own graphic here. So if I start using this one here, maybe that'll work. Let me try that. Let's do graphics there.add. There. Let's try that. Let's see if that'll let me kind of see what I'm trying to say. Come on. Okay, so now I've densified it. I've added that geometry. So this is the drawn one, but this one's mine. If I click on that, oh, you know, it's gonna be too much. I think I killed it. Yeah. Oh, my browser's crashing. I added too many geometries. Okay. Let's stop. Oh, crash my browser. Don't do that. Refresh. I'm gonna have to refresh this browser. Hold on. Let me refresh the page. I added way too many geometries to that. Okay. All right. That's my bad. Let's go for a different number. 25 meters, people. All right. So let's try this, and we'll be able to count now better. All right. So I had what, 1, 2, 3, 4, 5, 6, 7 vertices I drew, but my result came back with an array of 156,368 vertices. When I add one every 20, or no, I set the distance. I need a vertex every 25 meters. That's what the rule I set in. So that's why it nearly crashed my browser before. This number was 5 times greater before. So be careful when you do stuff like that, right? So that was my densify. All right. You see how that might come in handy. Difference. So the input geometry and subtractor. All right. So it just it's going to create the difference of two geometries. So the resultant geometry is a portion of the input. All right. So the first one, not in the subtractor. All right. So you're subtracting stuff from here. So if you put a small square and a big square, you end up with a donut square. So that would look something like, if you come over here, and we're going to go ahead and say the difference between this white boundary polygon and the buffers, which are going to be the circles in the middle. All right, so let's refresh this. Close that up. Let's expand. I want to make that expand not open by default. It keeps getting in my way. Where is that being added? There we go. Expanded, true. False. Stay out of my way, man. Refresh. Okay. All right, so now if I click test here, right? So everything that I give it this white boundary here and subtracted the buffer area from it. So that's what the black geometry is. Now it's just a giant polygon with some holes inside of it. All right, so that's how that difference works. Disjoint. Okay, disjoint's kind of cool. I dig disjoint. All right, it's got some pretty cool use cases. It's pretty much the opposite of contains. So if I come down here, we're checking to see if it contains a, no, that blue square that we're moving around. If it's contained in the boundary polygon, it's valid. But what if you want the opposite of that? Well, you can use disjoint. So I do not want to allow it inside that polygon, right? I want it, it must be outside. So as soon as I, oops, make some room here. As soon as I click on it, it's not, it should tell me, you know, this isn't allowed. Move outside, I'm now allowed. But if I click it and start going inside, I am no longer allowed because it should be disjointed from the boundary polygon. Get what I'm saying? So it works kind of the opposite of contains. Indicates if one geometry is disjoint, does not intersect in any way with another geometry. So that's how that works. Pretty cool. Distance, I won't cover distance. I think that's pretty self-explanatory. It's pretty great, right? You give it 2 points, and it's going to go ahead and return back a distance for you. And I mean, yeah, I see. To calculate geodesic distance between 2 points, first construct a polyline using the 2 points of interest as beginning and end length, then use the polyline's input for geodesic length method. Yeah, I guess so. Otherwise, I gotta ask what this note's about, because why would I, is this like to not use distance if you want to figure out 2 points? Or can these geometries be like 2 lines? It's gonna tell me distance between 2 lines. I don't know. But I should ask and find out. That wording is a little odd to me. I would assume they should be points, but I don't know anything, so what do I know? Equals. Okay, I won't show equals, because equals is hard, right? When we say equals here, it means they have to be the exact same geometry down to the decimal, right? Which is, I've seen people try and use equals before, and they have like a point on the map, and they try to click on the point and add a point there, but they don't want to allow overlapping points. They try to have this rule in there that, no, cannot be equal. It's going to be almost impossible for you to be able to click on the screen and get the exact same location of a point that you're looking at, right? I mean, it's just, you won't be able to do it. Okay, that's where snapping comes into play, and you should use snapping for stuff like that. But it's just difficult to do, and I've seen people try to do it, even with lines, right? It has to be the exact same geometry-wise with the paths and everything matching. So that's where equals comes into play. Still useful. It's still very useful if you have like 2 features layers, and maybe people are editing data in one and the other, and you want to make sure there's not duplicate entries, right? For something like that, maybe maybe it's like someone's adding street data over here and they're adding street data over here, where you want to find out maybe where there are slight differences between the two, and you can look at the equals and find out which geometries are not equal and kind of do some kind of versioning type thing off of that, right? So that'd be kind of cool. It's interesting. Don't know about extended spatial reference. Never used it. Don't understand it. Get off my lawn. Flip horizontal and flip vertical are kind of cool. So we can do that over here. So what I basically can go ahead and do is I'll click on this. You wouldn't notice on the boundary polygons, it's square. But if I did on buffers, you would. So let's do this. Let's do a flip. Come on. Horizontal. All right, refresh this. Also, if you weren't aware, the sandbox on the SDK for the JavaScript API will save any changes you make to it when you refresh it. That's saved in the local storage of the browser. And then you'll get a little thing up here saying that you can reset it to the original thing. All right, so if I flip this, bam, I just flipped it horizontally. Those are what the buffer geometries look like horizontal. If I flip vertical, refresh, it'll flip it the other way. All right, on the vertical plane, bam, flip vertical. I think that's pretty self-explanatory. And while I'm here, I might as well do this too. There's rotate, so you can rotate some geometries, and maybe let's try rotating them 45 degrees. Let's refresh that. I'm just doing it because I'm here. might as well. Rotate. Now you can imagine you could probably drive people nuts by putting this on like a set and a request animation frame and doing a rotate 1 degree every frame, and it's just spinning geometries everywhere. That'd be kind of cool. but it would probably drive your users nuts. But you know, you gotta have some fun every now and then, people. All right, so generalize. Okay, so generalize is going to go ahead and run the generalize operation on geometries that you give to it, right? So point and multi-point geometries are left unchanged, envelopes converted to a polygon, and then generalized. So, well, let's try it out. Let's see what happens. I don't think we're going to notice much difference here. Maybe if I fed it my densified bit. But let's try to see what generalize is going to do for me here. So let's come over here and let's do generalize, align. And what's the doc say? So max deviation allowed from geometry. I mean, I don't know. I'm going to pick a number here. And linear units. So, okay, wait here. So, whoa. Measurement unit of the max deviation. So what are the options? What are my options here? Okay, so I guess it's just like centimeter, yards, feet, miles, blah, 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 stuff like that, right? Looks like that's what it's talking about. Okay, all right. So I'm making sure, because, yeah, I wasn't too sure. A lot of this stuff comes from the, some of the old school Esri docs that you'll find out there, things for like arcmap, arc objects type things, because this is some pretty low level stuff that you start to mess with in here when you deal with geometry engine stuff, right? So we will do 25 meters because that's kind of like what we actually, let's do 250 and let's see what happens. Okay, so all right, so if I come over here, if I start drawing my line all crazy, all right, and generalize. Oh, I didn't add it. Let me add it. Yeah, okay. Refresh, save. Okay. Boom, 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 boom. I don't think, yeah, I don't think 250 is gonna be enough. You can't really tell. I mean, if I'm like super zoom in, maybe I could tell the difference. Some places, maybe very slightly. I mean, very slightly. Yeah, I mean, I was hoping I'd have some small differences here, but I think I have to go bigger. If I did like 2500, let's get nutty, right? Why not? See what happens. I mean, yeah, I'm not going to tell here. But yeah, it's still a fun one that you can play with to get used to. Yeah, you work it into your workflow if you want. I've never had to use it, but yeah, I can see a reason for it. I won't do these areas, geodesic area and stuff, because basically you give it a polygon, or I don't know, I guess you can give it an extent too, but maybe it wants just a straight polygon. And the units you want, like acres, hectares, stuff like that. And I think that comes from this, well, there's some docs somewhere about all the units available. You can click the link here and find it. And just give you the area. I mean, geodesic is going to consider the spherical globe, right, of the area that you want to get. And there's a planar area as well, where you just want a flat area. If you're working on a small scale, zoomed in, small, big, you're working on a zoomed in scale, like street level scale, like neighborhood type stuff, you could probably get away with a planar area. It'd be just fine. You're working at city level and anything above that, you're probably going to want to go with geodesic area to do a little better. All right, just take that curvature into consideration. Same with geodesic buffer, same consideration there, right? Okay, geodesic densify. We already looked at densify. Geodesic is just going to consider the sphere as well. Same with length, won't cover that. Intersect. Okay, so intersect is kind of cool. Creates a new geometry through intersection between two geometries. So if we look at the sandbox sample here, we did it before where this was the difference between two geometries is the empty space between the buffers and this polygon here. What do you think the intersect between the buffers and the polygon would be? All right, so let's try it out. So intersect. Anybody guess? Anybody guess? Anybody know? Anybody know? I would probably get it wrong the first time I thought about it. But no, I mean, you probably use this a lot if you've ever done some desktop stuff, I'm sure. So the intersection between the buffers and this polygon are going to be... Did I not? Oh, I'm sorry. Boundary polygon is what it's called. Boundary polygon. Wait, I don't want to give the answer away yet. It's going to be the buffers, right? That's the intersection between the... That's the common area between those two geometries, right? Is that buffers area. Okay, let's go down a little bit more. Let's look at some other stuff. Intersects is already being used over here. Again, it's just a Boolean thing, right? Let me put contains back to normal. So if any part of the geometry intersects with the other part of geometry that you are checking against, you'll get back a true. If they don't, then you get back a false. All right, so okay. So I think that's very straightforward. Is simple. Now, I've never used this one, but it's probably pretty useful for getting geometries back from the server to check to see if they are simple geometries, topologically simple. And I don't necessarily know what a topologically simple geometry is. I'm not that smart. I would hit up Christian Economist to find out exactly what that means. In terms of, like, you know, you're building an app, where would you care about that? But let's just let's go ahead and remove this, and let me just say is simple. I don't think I can actually draw a non-simple geometry myself with a sketch widget. I don't think it would let me even draw a non-simple geometry, because I don't think it's about like overlapping itself and stuff like that. So if I draw a line, right? I mean, it's still simple. There's nothing not simple about that. I don't think the sketch widget will let me draw not simple geometry. So there's that. But it could be pretty useful if it does do stuff. There is a method to simplify geometry. So if you come across a condition, a use case where you're getting non-simple geometries for whatever reason from your service, you could simplify them. Or no, check if there is simple, and then simplify them, and then you could use them for whatever you need to use them for, right? But again, I don't know what the use case for that might end up being. It could be like a bad edit in arcmap or something, or I don't know. I honestly, I couldn't tell you. I'm just guessing at this point. Nearest coordinate. Okay, so there are these nearest methods too. It's nearest coordinate, nearest vertex, and nearest vertices that kind of operate in a similar manner, right? You basically give them a target geometry. It could be an extent, a polygon, some more lines, and you give it a coordinate of some sort, right? Input. And then what is the nearest coordinate or vertices to that? Now I'm going to steal this demo from Christian here, who did this sample here for the nearest vertices, right? So it's clicking this. This is 3x. This isn't 4x. Remember, the API for GeometryEngine is the same between 3 and 4. And it goes to nearest coordinate, right? Look at that. Oh, that's nice. Man, that's cool. I dig that. That's a pretty cool demo, right? And you go inside, and now you get the nearest vertices. See, just the vertices. And see, it's not along the line, but if I come over here nearest coordinate, I'm now working along the line, right? Bam. That's cool. And I mean, the code for that looks something like this, right? You pretty much just pass it the polygon and the point, and you know, then here he's checking to do the whole is, you know, if you're checking coordinates or not. Here's the nearest vertex, again the polygon, the point, and yeah, I mean it's pretty straightforward. The nearest vertices would just get multiple vertices, right, to give you your answer. So that's a really cool demo. These are really useful, and as you can imagine, they're used for like the snapping in the JavaScript API, right? And if you combine like snapping with editing, you have a really solid editing experience to do with your apps. But if you need to take your editing a step further, you can start incorporating things like this along with some of the checks like, you know, overlaps, contains, intersects, and stuff like that in your editing tool, and take it a step further if you want to do some pretty hardcore stuff. I've done some of that kind of checks editing tools in the past. It's been a long time. It was on 3x and stuff, but it's super powerful stuff, especially for your users when they're using it. They can click a checkbox or something like that, or define some rules in the app. And yeah, it's really cool. Offset. Okay, offset's kind of cool. So offset pretty much is going to do the opposite. Well, not necessarily the opposite. Offset works like buffer, except to one side, right? So if I come over here to the sandbox one, and let's come over here, we'll do the whole button click thing, right? I'm going to do an offset here for the boundary polygon. And I'm going to do it by 500 meters. That might be a lot. I don't know. I'm gonna learn my measurements someday. There we go. So offset. So again, I'm not buffering the polygon. I'm doing an offset of it inside, right? To basically create a smaller version. Now this is kind of useful. I can take this offset, clip this polygon, so I'd have a donut, and then do some like cool shading in here or something like that. And now you have like this cool effect you can add to your app. Maybe you apply like filters and effects or something like that. Maybe some blend mode on this for your app, and you have this nice little like shaded area of your map to highlight an area of some sort. There's some cool things you can do there. And then you can just get rid of the geometries after the fact because they're not really part of your features. Not there, just save them in the app or something like that. Ooh, save them in local storage. So when you refresh them, they come back. That's cool. I come up with dumb ideas all the time. Nobody really appreciates them, but no, they're ideas nonetheless. Overlaps. Okay, overlaps is kind of cool. So if read it here. So indicates if one geometry overlaps another geometry, right? So let's just give you an example of what that looks like. Let's go ahead and change some of the rules in here. Where we said, where's my contains here? Contains. We're going to change contains to overlaps between that blue geometry on here and the white area. Okay, so if I click on this, this area is overlapping that geometry. Did I see here? Yeah. Refresh. Let me make sure I did it right. I am doing it right. Yeah. So this overlaps and then it doesn't overlap. Overlaps. Boom, boom, boom. I'm doing something else. Did I spell it right? Yeah, I did. That makes sense. I thought I would have done it over here, like not allowed it. But I think there's other stuff happening in here that I am not taking into consideration. There you go. So yeah, overlap is kind of fun. I thought overlap would have done it here. And I'm pretty sure I jacked the sample up at this point. I've modified it so many times that I've broken something. Oh no, I want it to overlap. So it doesn't overlap. Now it does. So that's why it's blue, because I'm allowing it to overlap. It's not contained. It's not disjointed. It's not overlapping. Here it's overlapping, meaning that it covers both sides, in and out of geometry. It's overlapping it, right? So I don't care that it's actually contained or not contained, just that it's overlapping. You get it? The English language, my friends, I'm telling you. Planar area, I'm not covering areas, not covering length. Relate. Okay. I don't know who the hell did this one. Or it's part of the GeometryEngine as a whole, platform-wise and all that. But I don't know too many people that use it. If you do, drop me a line. Let me know if you use it and what you're using it for and how you're using it. Because I'd be really interested to know. All I do know is that it's a super powerful way to do some stuff with GeometryEngine using this dimensionally extended 9 intersection model. I have been doing GIS since 2002. I don't know what the hell that is. That's beyond me, right? So don't feel bad if you don't. I don't. I should probably look this up and get a better understanding of it. But basically what you do is you give it two geometries, right? Geometry 1, geometry 2. Now the relationship is defined by the string that you give it. That string is over here in these relational functions, right? And I'm guessing you can pass in a combination of like true or false, or I think star might be both. I don't know. Or I don't know where the star comes into play. Is there better documentation at top? Tell me what each of these means. So this explains it. Okay, so T intersection must exist. F intersection must not exist. Star, it doesn't matter. Don't care. 0 must exist, and its maximum dimension must be, and so on and so forth. So you combine these values to various strings, and you can do some pretty cool stuff. So you can recreate basically what contains does, what crosses does, and under the hood, maybe this is just like the low level what GeometryEngine uses. I don't know. I haven't looked at the GeometryEngine code itself. So maybe this is what GeometryEngine code does under the hood. You use this relate along with these different strings to do stuff. All right, they're predefined somewhere. So okay, let's take a look at this now. So I'm gonna copy this. It says this string here is going to test whether a polygon geometry completely contains a line geometry. So let's come over here and try that. So I'm going to take my line, I'm going to do a relate, and I'm going to do it against my polygon, and I'll pass this dim9, D9M? What was it called? I already forgot what I'm doing. DE9M. I'll pass the string to this relate method here. All right, wrong one. Where am I at? Here we go. Okay, so this should tell me whether or not the line's in or out of my polygon. So let's draw a polygon. I'm going to draw a line. False. Right, it's not in there. Now if I draw it again, true, it is in there. Okay, cool. What if I change one of these to false? I don't know what this is going to do. It's probably not going to do anything. It's probably just not going to work, period. If I draw a line, I mean, it said false. False, right? So now I broke the whole thing. I don't know what this is doing in terms of the relationship between those two geometries now. But you get the idea. So again, if you use this relate method in your applications, I'd be really curious to hear like how you're using it, what you're doing. If you're doing something that maybe is not in GeometryEngine, like one of the methods that's not provided by default, and you're doing something a little custom, I'm curious, man. I'd love to hear about it. So let me know. I would like to try and learn how to do this better. Oh, what's this one done? So ignore relevant intersections or dimension form. I don't know. I'm not going to try these, but you get the idea. Try it out. It looks like fun. I mean, I dig stuff like that. We looked at rotate already. We kind of rotated it. Oh, you can also set the rotation origin. So give it a point. So if you want to rotate instead of off the center, maybe you want to rotate off the corner or something like that, you can do that. Rotation, that'd be kind of fun. Like a nice little animation of geometries. Just start messing with people. Simplify, we kind of talked about that. Symmetric difference works like difference, but it only includes parts that are in either of the sets, right? But not in both of the sets. And I don't really have a good example to show symmetric difference, so just give that a shot. It's very similar to difference. Touches. Now this one's tough. I don't think I can really demo touches because I can try, I guess. Let's see. If everything's on the same layer now, so let me try something here. I thought I had my... No, I don't have snapping to other features on here. Basically, what touch is going to do, it's going to tell me if this point, for example, when I draw it over here, right, does the end of that line touch this line? But it has to be like right on the edge, right? It's like a node to edge touch. It's not does it cross it. It's not is it before it or is the end point after it. Directly touching the edge. So that's going to return true in that case. If it doesn't touch the edge, then it's false. This would be true in cases when you're dealing with snapping. That's how it gets that area to touch it to. And do I need to do something here to set my snapping? I do, but I don't know snapping very well on 4X yet. Although I've been playing with it a lot. I think I should know it as much as I've been playing around with it. But yeah, you could turn that on and have it in here and test this out. So that's what touches mean. So if you use it, you're a little confused in terms of like, why isn't it true if the line's crossing? It's not that it's crossing. It has to actually touch the geometry, just like a little, right? Just a little love tap, that's all. All right, union. Okay, union is pretty straightforward. I mean, I'll show it. I don't know if it's going to make much of a difference. Let's try it here. Let's do this. Right. So if I on button click here, if I union my two geometries, I'm going to union the boundary and the buffers. See what happens. Just get one big old geometry, right? They combine them both together, and you got single geometry. Bam. So I think that's pretty self-explanatory. Union is pretty useful in a lot of cases. You typically give it, say here it says you can give it an array of geometries, but it actually does take, it can take an array of geometries, or you can just pass it, you know, an argument of geometries. That apparently works here. So yeah, that's cool. I think I did it right. Maybe it doesn't do that. Maybe I need to do the array. I didn't get an error, so let's clear that up. Try it again. Yeah. Now if I want to check something. If I just pass buffers, is it gonna still do it for me? Like a single geometry? Yeah, it does. So it could have been passing the this too. So let's try this. Now we're just testing this out to see if it's doing what I think it's doing. Yeah, it does. So you can just pass an argument in geometries. This came up before. We noticed this when using Union the API, that the doc says it's I mean, it says geometries, but here, like an array of geometries, but I think it could be just an argument of geometries. It's probably safer to pass an array anyway and not rely on number of arguments, right? So yeah. Within's cool. So indicates if one geometry is within another geometry. I mean, it sounds like contain to me. Let's see here if there's any difference. So if I come down over here to where I use contains, let's change that to within. All right. And refresh that, and let's see what happens. See, does it going to behave the same way? I click this. No, apparently not. I don't know what would define that being within there. This geometry is within that geometry. Is it the order, maybe? I could... Inner geometry, outer geometry. So I'm doing it backwards. So it takes the arguments in a different order than it looks like contains does. So if I come back over here, let's change this to the inner geometry. All right, put it over here. And now I have the outer geometry, right? Reading that inner geometry, outer geometry. That's why it says that. I probably should have paid more attention to that doc. Refresh. Yeah. There you go. So it works like contains, but just different argument order. That's fine. That's cool. I can get behind that. No big deal. All right. And then these are just type definition. Okay, so that was it. That was all of the geometry engine functions that we went over. Oh, a cool thing, if you do like the nearest point stuff, nearest coordinate and all that, you get back this nearest point result, and that's going to come with the distance already. So you don't have to, if you need to know the distance to the nearest coordinate or something like that, you don't need to take your input coordinate and the nearest coordinate you got and do like a length measurement or something like that, or a distance tool. It'll already come in there for you, so you don't have to go back and do it. Is empty? This still throws me off, and I gotta ask somebody about this. I'm not sure what use case you would have where you'd get an empty geometry back to the nearest point, nearest vertex. How would it know? Why would you get that vertex back if it was an empty geometry? You know, sometimes I don't ask questions because I don't want to know the answers. But there you go. Like I said, if you have any questions on Geometry Engine, feel free to drop me a line. I can't answer them, but I could probably find you someone, Christian, that can help answer them, and I can bug him about it, and I can learn something too, right? And again, I really am genuinely curious if anyone's using that relate method in their apps and how you're using it. Maybe you can teach me how to use it. I'd love to know. Maybe I could do a whole piece on just that. but I'm definitely not smart enough to cover this with any real knowledge of my own. But I would also recommend if you hit up Twitter, just hit me up with any questions you got there. Drop any questions on YouTube channel, whatever you got, and we'll try and cover some stuff for you. So don't forget to hit like, drop a comment, and subscribe. Thanks a lot. See you later.